Hey kids, Smath here. Little kitchen chemistry for you today. We're going to simulate, actually, we're not going to simulate, we're actually going to do a lab where we're going to find the specific heat of this metal. Welcome to my kitchen. You've lived in my virtual background. Now you're living in my real kitchen. What I have is a block of aluminum, and I want to find out what the specific heat is. And I know a lot of you guys are just saying, well, hey, why don't we just look it up? Yeah, where do those values come from? And that's what we want to do today. We want to see where those values come from. So I've set up a little data table here. And what we're going to do is we're going to measure some of the aluminum, and we're going to use water as a known value to calculate the specific heat of aluminum. That's what we're looking for. Now, this is thermo. We've been doing a lot of MC delta T's to figure out energy. What we're going to do is bank on getting this block of aluminum hot. And as a matter of fact, I'm going to get that going right away, and then I'll explain the theory a little bit. First thing we need to do is find out the mass of this. So we're going to pop that on a scale, and we're going to get the mass of that. You got to trust me here, 5989 grams. So 5989 grams. And now I want to get this warm, so I brought home some stuff, some toys to play with. I'm going to place this down into this water and just let it sit there for a few minutes. Let it get hot. You can see the steam coming off of that right now. We've got that up right around boiling, so it should be pretty close to about 100 degrees Celsius. Let me get back to the theory. What we were doing is we're going to get the block of metal hot, put it into some regular room temperature water in a styrofoam cup, and measure how much energy the water absorbed. The water absorbing energy is going to come from the metal losing that energy. So between the two, we should be able to figure out the specific heat. Remember, excuse me, MC delta T. I just got the mass of the aluminum. Let's get the mass of the water. I've got a graduated cylinder here, and I've measured this out so that my water is at 95.5. I'm going to pour that on in there. It's at 95.5 mils, and we're going to trust that that's 95.5 grams. I could put the styrofoam cup on the balance and weigh out the water as well. I still should get something very, very close to 95.5. So now what I need is the initial temperatures of both. So I've got a thermometer here. Pop that in, turn that on, and bada bing. And I'm going to put that in my water. I'm going to stir this up. And the initial room temperature of my water is 24 degrees Celsius, pretty close to room temperature. I'm going to let that just sit right there. And TI of water is going to be 24 degrees Celsius. And now let's see what our temperature, I mean, this puppy's about boiling, right? I mean, it's steaming up awful hard. And I've got 99.0. Stay. So 24.0, 99.0 degrees Celsius. Now the hard part. Now we're going to take this block of metal out of here. I'm going to get my thermometer in. I'm going to get it turned on. I'm going to take the block of metal out, put it into the cup, and swirl it around and measure the temperature here finally. Okay, this has to happen pretty quick. I don't want to lose any energy. Ready, set, and go, and swirl, and swirl, and swirl. It's going up. 29, 30, 32, 32, 3, 32, 4, 32, 5, 6, 7, 32, 8, 32, 8, and 32.6. And we're going down now, 32.6, 32.5. So 32.8 was our highest temperature. Stay. Now that was the final temperature of both. Now what we can say is the water absorbed all the energy from the metal. So what we can say is MC delta T equals MC delta T. Just keep in mind now, the metal was hot, it lost energy. We're going to put a negative sign out in front of that. So now let's plug in our players. Negative 5989 C times TI equals the water side we know 4.18 joules per degree Celsius, and the water temperature change was 32.8 minus 24. You guys should be able to see that. You should be able to work through that. What I'd like to see is for you to clean this data up a little bit, make it real pretty, do the calculation, send me a picture, email me a picture of, actually I'll create an assignment. I'll create the assignment and turn it in there. Tell me what the specific heat of aluminum is. And remember, if you want to make your odds a little better, look it up online. This data is pretty good. I'm Smath. I hope this video helped you.